We're going to start off this lecture looking at oxidation numbers within compounds. So again, this is something that you may want to go back to the book or the PowerPoint in which I go over these ideas in a little bit more detail. I'm going to make the assumption, I'll talk about some of them, but I'm not going to go into great depth as to why they have the numbers necessarily. A lot anyways. All right, so what we're trying to do in these particular problems, number 17, is look and say, okay, if this has an oxidation number over here, how did it change to the oxidation number it has over here? Looking at this particular compound, one of the rules we looked at in a previous video is oxygen within a compound is usually 2 minus 2. And I've got 5 of them here, so the overall for this particular oxygen, it's contributing a minus 10. So iodine has to pick up the slack and balance that to give us a 0 charge overall. So iodine also is positive 10, but I have 2 of them, so therefore it's positive 5. So oxygen is something I typically don't worry about unless it's in a peroxide. In this example here, oxygen again is going to be a 2 minus, so therefore carbon has to balance it out and be a 2 plus. And then in this compound, iodine, is a 0 because it's elemental form. And then this one over here, oxygen 2 minus, so minus 4, carbon is plus 4. And now we can talk about the changes that are taking place. So what happened to iodine? Iodine went from positive 5 down to 0. So if it gained negative charge or electrons, therefore it was reduced because it gained. It is reduced from positive 5 to 0. So it gained a bunch of electrons in there. Then carbon in this example went from positive 2 to positive 4. So it lost 2 electrons, and I'm talking about each one. So carbon was oxidized because it lost electrons, oxidized from positive 2 to positive 4 for each one. There you have it. Let's look at B. B, you have mercury is positive 2, and here it is 0. That's pretty straightforward. And then in this example here, we said hydrogen typically acts as positive 1. So in this particular example, so it's positive 4. And so this is negative 4 divided by 2. So negative 2. Nitrogen, of course, is going to be 0. And hydrogen, of course, is 4 plus. So hydrogen didn't change at all. Oh, excuse me, 1 plus each. Hydrogen did not change. It was plus 1 the whole time. But mercury, we can see that changed. So we'll say mercury. It's it's gaining 2 negatives. So it's gaining, being reduced from 2 plus to 0. And then nitrogen looks like it's going from 2 minus to 0. So it's losing or being oxidized from minus 2 to 0. Okay? Let's look at part C. In this example here, we're looking at hydrogen is going to be 2 plus. This is going to be 2 minus or minus 2. Hydrogen, of course, is 1 plus. Is that going to change at all? No, I'm going to skip over that one. Nitrogen, this is a good one. Oxygen is 2 minus, so 6 minus, but it comes up to 1 minus. So in this case, nitrogen is plus 5 to make that happen. Sulfur is 0, so I see a change there. And oxygen is 2 minus, so nitrogen is plus 2. And these guys didn't change. I'm going to ignore that. Okay, so let's see. Sulfur went from 2 minus to 0, so therefore it lost its 2 electrons. So I want to go the other one first, just to be consistent. Nitrogen goes from 5 plus to 2 plus, so it is gaining, meaning that it is reduced, going through reduction. So it's reduced from plus 5 to plus 2, gaining electrons. And now we have, what do we have, sulfur? Sulfur is being oxidized, and why? Because it's going from -2 to 0, so it lost 2 electrons. So it is oxidized from -2 to 0. All right, one more in this little example. We have barium. Barium is 2 plus, and over here is still 2 plus. All right, that's fine, no change. So I can kind of ignore barium. In this example, usually those don't look like they're going to do anything, but here I know I'm going to have a big change. This is a peroxide, so oxygen is -1 in peroxides. Hydrogen is still going to be +1. Okay, no big deal. And this is an oxyana. I can see, not an oxyana, a oxygenated halogen. So here, this is going to be -2 each, so -4. So chlorine, believe it or not, in this example is going to be +4. Chlorine is +4, so it's got some options. And then going back over to this example, this is a little bit messy. Within this compound here, based on the charge it put onto barium, it is -1. So oxygen here is -2. I've got 2 of them, so -4. So chlorine, therefore, is going to be picking up the slack, and it is going to be +3. So let me remove this, which I put down for barium before, and write +3 specifically for chlorine. So +3 for chlorine there. And then going back to this oxygen, I can talk about this one or talk about that one. I think I'm going to address the oxygen right there. So the hydrogen I'm going to ignore because the hydrogen didn't go through any changes. I just don't want to see it. So I can really kind of focus on the ones that are going through the changes. It's fine if you leave them, it's not a big deal. But I want to focus on the ones that are going through changes. The chlorine went through a change. This oxygen here went through a couple changes. And this one I did not write over here was -1 in the peroxide. So there I have my examples. Okay, let's do chlorine. Chlorine goes from 4 plus to 3 plus. So therefore, chlorine must have gained an electron, which is reduction. So +4 to +3. And then oxygen is going from -1 to 0. So it's lost an electron. So oxygen is being oxidized from -1, to 0. -1 to 0, going through that oxidation process. All right, we'll get started on 21. I don't think we're going to finish it in this video, but we'll go ahead and get started. Complete and balance the following half reactions. In this case, indicate whether the half reaction is oxidation or reduction. And looks like most of them are basic solutions. So no sweat. We already did this once before. If I go through this equation here, I'm going to go ahead and write it over on the side so I have a little bit more room. Give myself a little bit more room. And we'll say 10, 2 plus, turning into 10, 4 plus. Okay, so you have those rules from the previous video. Hopefully you have this written down somewhere. I don't have to do any oxygen or waters or any of that stuff. I only got to do the charge. So to make the charge balance out, I have to get from 4 plus down to 2 plus. Let's throw in 2 electrons. Fantastic. I think I need to put an arrow instead of a plus sign here. For this particular process, I have lost electrons. There they are, they're lost. That's oxidation, that process. If I'm doing this one here, also in a acidic solution, okay, so I'll do the whole balancing the oxygens by adding water, and then I'll balance, how many I need there? I guess I need 2. And then I have to balance the hydrogens. There you go. And I have to balance the charge. So I have 2 plus and 4 plus. Let's go ahead and throw in 2 more electrons. And it's all balanced out. Now, as far as electrons being over here on this side, it is gaining electrons. So that is reduction. All right, let's go ahead and do F. I guess we will get through this. We have OH turning into oxygen gas. So to balance the oxygens, I guess I have to add in some water, or add in some water here. It needs to be in a basic solution. It looks like I'm kind of already there. So the oxygens to balance off that part here. First, I actually have to make this part's good. So the oxygens are now fine. And then it says I have to make sure that the water parts, so I'm going to add in 2 hydrogens, but it needs to be in an acidic solution. Or I'm sorry, a basic solution. So right now this doesn't seem to work out. So I'm going to add in some more hydroxides. Why not? And now I got to make sure the charge is good. So this cancels itself out. This over here is 4 negatives. So to balance that part, I'm going to put 4 negatives over here. So ultimately what this one would look like is I have 4 waters. And do I have any waters over here? Yeah, looks like I have 4 waters here as well. I think as far as the total goes. Actually, this is going to be 4 hydroxides. And over here, let's just go ahead and say this is going to be 2 waters. So I'll have 4 hydroxides. Still going to have the oxygen. And we'll go ahead and say we have 2 waters, because these guys are going to go together. And then have my 4 electrons. And of course, because I'm losing electrons, that is oxidation. Done. Let's see if I can squeeze this last one in here. It's going to be a little bit tight. I've got sulfur, or sulfite, turning into sulfate. And to make that work, I got to get the oxygens to balance. So I'm going to add in a water. And then if I do that, I got to balance out the hydrogens. So I'm going to add in 2 hydrogens, but then it needs to be basic. So I'm going to add equal portions of hydroxides to both sides. All right. And the charge here just cancels itself out. So over here, it looks like I'm +1 looking at over here, because this one here is going to be the same as over here. So I guess I need to put a 2 electrons there. So again, as far as the final outcome, I'm going to have, this is 2 waters, and I've got 1 water here, so that's gone. And this is going to end up being 1 water. And just for the sake of not having to write too much in here because it's kind of cramped, this will stay, this will stay, this will stay. I've got 1 water and 2 electrons. Done. That's the end of the lecture.